Out in the freezing dark of deep space, the James Webb Telescope is staring at a distant point of light. Hidden within that glow is a mass billions of times heavier than our own sun. It pulls in surrounding stars and crushes planets. The gravitational grip is so severe that light itself remains trapped if it crosses a specific threshold. This is a physical reality observed by astronomers, an object capable of tearing a human body into subatomic particles. The universe is filled with these silent, insatiable predators, watching from the dark, utterly indifferent to human survival. Welcome to eduminded. We take the most complex mysteries of the cosmos and break them down into something you can actually picture. Today, we are looking at black holes. These are regions where matter is packed so tightly that it warps the fabric of reality into a bottomless pit. To understand how they work, we have to look at exactly what happens to your biology and to time itself if you get too close. The process begins when a supermassive star runs out of fuel and explodes outward in a supernova. The remaining core collapses inward, packing an immense amount of matter into an incredibly tiny space. Imagine taking the entire mass of planet Earth, every mountain, ocean, and continent, and crushing it down until it fits inside a chickpea. This extreme density creates a localized gravitational pull so intense that the normal rules of space simply break down. In 2026, data gathered by the James Webb Space Telescope revealed supermassive black holes in the early universe, growing at rates that defy our current understanding of physics. These objects sit outside standard physical laws, acting as silent anomalies capable of consuming entire galaxies. If you approach one, you eventually reach the event horizon. Once you cross this invisible line, no amount of energy can bring you back. Because the gravity increases so rapidly over a short distance, the pull at your feet is millions of times stronger than the pull at your head. Astrophysicists call this biological stretching process spaghettification. Your cellular structure cannot withstand the differential force. You are pulled into a long, thin stream of matter before fading into absolute darkness. Crossing that boundary results in the violent mathematical unmaking of your physical form. The influence of a black hole extends to the passage of time itself. This is time dilation. The extreme density of the black hole bends space so severely that the passage of localized time drastically slows down. While your clock barely ticks, the rest of the universe keeps moving. Behind you, stars are spinning, aging, and dying at hyperspeed. A single minute experienced near the event horizon translates to decades or even centuries passing back on Earth. Surviving the descent would leave you irrevocably stranded in the distant future. Everyone you have ever known would be long gone. When we step back from this localized destruction and look at the wider universe, a different picture emerges. We find these supermassive anomalies at the center of nearly every galaxy. Their immense gravity is the specific force that holds these massive structures together. They dictate orbital paths of billions of stars, preventing them from drifting aimlessly into the void. Without these central gravitational anchors, galaxies would scatter. Their presence allows the universe to organize matter into stable, rotating systems that permit planets and life to exist. Thank you for joining us on this journey. If you appreciate our deep dives into space and want to support production of this channel, you can buy me a coffee using the link below. Intellectual curiosity is what keeps eduminded going. Be sure to subscribe and engage so you don't miss our next journey into the unknown.